Hello, I'll demonstrate how to perform optimal power flow using the open-source Electrisim software. We will use free available template, which you can use in your browser at app.electrisim.com. Optimal power flow is a mathematical tool used by power system engineers to figure out the best way to operate an electrical network, balancing cost, safety, and efficiency all at once. We'll continue with our example network, which is based on a Panda Power tutorial. You can find the link directly within the model, freely available at app.electrisim.com. The system consists of an external grid, a two-winding transformer, two generators, loads, and lines. Scenario 1. Loss minimization. In the first scenario, we assign identical costs to the external grid and all generators. When all generation costs are equal, the OPF has no price incentive to favor one source over another, so it minimizes the total amount of power injected into the network, which is mathematically equivalent to minimizing network losses. As a result, the loads at buses 3 and 4 are served by the generators connected at those same buses, while the load at bus 2 is supplied by a combination of the remaining generators, arranged to minimize transmission losses. The resulting dispatch cost is also displayed. Scenario 2. Individual generator costs. Next, we assign individual cost rates to each source. 10 euros per megawatt for the external grid, 15 euros per megawatt for the first generator, and 12 euros per megawatt for the second generator. After running the OPF, all active power is supplied entirely by the external grid, the cheapest source available. This is the expected outcome, since no additional constraints have been defined yet. Scenario 3. Transformer loading constraint. Because all power flows from the external grid through the transformer becomes heavily overloaded at around 145% of its rated capacity. We now impose a 50% loading limit on the transformer. To respect this constraint, the OPF redistributes generation between the external grid and the second cheapest generator. As expected, this comes at a higher dispatch cost. Scenario 4. Line loading constraints. We now examine the line loadings and apply a 50% loading limit across the lines. The OPF adjusts the dispatch accordingly to keep all line flows within the new limits, again resulting in a further increase in dispatch cost. Scenario 5. Bus voltage constraints. Finally, we introduce voltage constraints by adjusting the allowable voltage band at each bus bar. The OPF ensures all bus voltages remain within the specified limits. To achieve this, all generators contribute to supplying the loads, and dispatch costs rise once more as a result. Electrisim also supports DC optimal power flow and other options such as piecewise linear cost functions, which we will cover in next tutorials. Please subscribe to get notified.